So I'm going to start the recording and go through. It's 21 minutes past 12. So like I mentioned before, this presentation is going to be about the key learning points that we learned by testing about 120 or so, maybe a fewer, because some of the VMs couldn't be tested at the end. Azure VMs with a SAS Base code. Before I jump to the session, let me very briefly explain who are my SAS team. So my SAS team is part of Analytium Group, and this is our focus on SaaS technology, digital portal, and function, where we're offering various software solutions, SaaS licenses, and SaaS services specifically aimed at SaaS and related ecosystem like Azure, for example. We have about 25 people working for us at the moment. We are Silver SaaS partner and reseller. We're Microsoft partner and reseller, and we also have 2 competencies in Azure space for data platform and data analytics. Most of the industries, just historically, because of where most of our expertise lies, is actually banking and insurance. And at the moment, most of our revenue also comes from SaaS. Now, we have technology partners, SAS, Microsoft, and we also work with AWS, regional partners such as Laco. Some of you know them pretty well. And we have a variety of customers, again, primarily banking and insurance. The nature of the test. We are moving customers into the cloud very actively at the moment, quite a few of them, some of them at the same time. And Azure offers a lot of various types of VMs. Customers, of course, execute the batch processes. And the question was, what needs to be done to speed up some of that batch process, and which VM type offered the best performance? What we wanted to do, we wanted to measure CPU performance only and exclude all other things out of the picture. CPU performance only, exclude all of the picture. And we wanted to make sure that we don't depend on a disk, on RAM, and don't go into the discussion where the bottleneck is for the execution. We tested on Windows, although we are planning more tests on Linux next time. And it was also SAS version 9.4M7 that was used for the testing. Now, when it comes to the code that we used to do the performance, it's this little macro that we very helpfully borrowed from a Stack Overflow answer, typically go on Google. What it does, if I very quickly try to explain, it simply creates arrays and then uses those arrays to create numerical and character columns. We don't store them anywhere, so you could see out data is equal to null because, again, we don't want to be writing to disks or memory. So we plain and simple generate. This test can be very quickly and easily repeated on other platforms. In fact, I could put the code later on in chat, and then you could try it on some of the platforms that you have. The data that I will be presenting is actually available right now. It's not commercially sensitive, and the dashboard, the screenshots of which you will see, is also available on our sasanalytium.co.uk platform. It's important to say this is only available for the live session that we're doing right now, and some of you should be able to log in. I see the chat. I see that it doesn't look like anyone has any problems connecting to it, and you could explore the data as and when I present. This is very much up for discussion. Raise any questions, stop me at any time. This is not set in stone. So let's begin. One of the lessons that we learn here, that high CPU core, specifically the single core CPU speed, it tends to be one of the best performers for this. If I represent the graph where we looked at VM price per run, so we run the SAS code, and then we'll calculate how many times we can run over how many instances in a day. The best performing instance for that particular SAS code is DC1 SV2, which gives the lowest run. So interestingly enough, if you have a look at what that specific VM time can do, it offers by far the highest CPU core speed. The drawback, you can't get an instance that has many cores. So if you, for example, run a load that runs multi-threaded code or runs other software on it or requires many cores like a 2048, those instances not available. But on the other side, for a single-threaded processing of SAS code, which most of it is single-threaded, that by far gives the fastest performance. And when I say performance, it's in a number of runs that possible to squeeze in a day, and also the total time of single performance. If you compare them side by side, what you get here, the number of runs that you could do in a day. So if you were to run the same code for the whole day, you could execute it 1,240. I will come back to the number of cores. DC type is actually the subset of D series. So you won't be able to find it as a separate series. It's a sub-series of VMs for the D series itself. The other interesting learning point that we got, and that went against the common wisdom that we got from SAS and some other papers, AMD actually performs better than the most common Intel. So if you take all the other VMs that we have on Azure, that you have access on Azure, you exclude the DC type, the next best performance is actually AMD based. If you was to select by AMD type, all of them perform roughly the same. You could get about 1,000 executions a day, when the next best Intel offers about 9,001. Interestingly enough, AMD at the same time is cheaper. So it's cheaper than most of the Intel machines. So side by side, if you're not going after the most executions a day, AMD becomes the best outcome. The next one here, bigger isn't better. So on this graph, you could see all the VMs that we tested. They are colored by series size. You see the DC machines on top, and because the SAS code, like a data step code, is single-threaded, throwing more CPU cores at it doesn't make any difference. Making the machine bigger doesn't make any difference. Various types of series perform similar, but you will see some later on. Clearly, A series belongs in one cluster, and it's actually tend to perform pretty bad. The B series tend to give the best value to money, and then DC series tend to perform best, and the D series roughly lie in the middle. So that's about the A series machines, which are usually seen as a cheapest one. B series is a special case that I will touch on a bit later. With the A series, they are very much at the low. So if you look at comparison DC versus A, cheaper isn't better. Actually, per run, if you were to take a machine and you run the SAS code on it for the full day, it actually ends up costing you more per execution because the number of executions a day is so much less. So again, you would need to think about for your type of workload how that best fits together. But the cheaper isn't necessarily better in this case. And the last one, I think that's the last one for this one, is the B series. B series is compute burstable machines on Azure. And what that means that when you're not using CPU intensively, when you use below the baseline, you accumulate CPU credits, which then can be used to burst the performance of the CPU overall. And in these instances, where you find that this particular VM for a relatively short executions gives you by far the best value to money because they don't cost much. Some of them only cost like £6 a month. I'm not sure how that is possible, but that's the case, and gives you a very good performance. If you imagine a scenario where you only have users connecting sometimes, when you only have occasional batch runs, then this type of VMs will give you the best performance to your budget compared to even DC type. When DC type will perform best when you have a consistent throughput that you need to guarantee for 24/7. The B series, once you used up your credits, you will see the performance plummeting significantly. And the last one, this graph on the right hand side, you see the cost of the VM per month in this case, summarized per month. And on the left, the number of times you can execute that SAS test code on it one after another. Or what this graph very clearly shows that again, the more expensive VM size, it really doesn't necessarily address how many times you could run it on it. So some of the VMs where you end up paying more tend to perform less, or the other way around. It's important to note that when you work with Azure VMs and when you work in the cloud, you need to very closely keep an eye on your execution, on your batches, and the workloads that you experience. In fact, I would like to very quickly promote one of the aspects that Analytium and my SAS team does. One of the ways that you could estimate your needs for Azure is if you can monitor your workload on-premise or in Azure exactly. And one of the ways of doing that is with SAS Monitor, the solution that we have built on the back of Zabbix, and also using open solutions like Zabbix themselves. If you want to know more about it, I would be more than happy to show you after the call. So what's next? I'm really looking forward to a discussion and the questions that you might have. But we're going to carry on testing more. We would like to see how this sort of tests will perform when we change the Linux OS, especially that Linux VMs are so much cheaper on Azure or other environments. We would like to configure, and I would be interested to hear some advice on multi-threaded code tests on Azure, especially how we could possibly set up the multi-threaded code that doesn't necessarily rely on memory or disk. We are looking at making this a highly repeatable exercise. So right now, with our test methodology, where we're executing several times manually, aggregating the data manually, we're looking at completely automating VMs restarts and do it in a large clusters of the machines to make this test highly repeatable. So when VMs type changes, when new CPUs become available, we can get these benchmarks. And we, of course, would like to carry on and test these scenarios on other environments, such as AWS, GCP, DigitalOcean, and maybe some in the future, some other public clouds, like, for example, Red Hat, Redshift. Perhaps other ideas. If you have any other ideas, such as creating a public database, allow other people to submit the results of their test for the same code and versions of SAS. Perhaps also find a way of testing on-premise CPU, so then people could reliably compare should they go to a hardware provider available for on-prem and which CPU they should buy compared to the cloud. So I see in the chat there's no questions, so I would like to open up to the floor. Any questions?
I think it's very interesting, Vasilij, the analysis about the different machine types. I think where it might be useful for people who are considering purchasing SAS or thinking about architectural options, about when they're setting up their machines, a lot of clients would probably say we want to settle on one machine type to avoid the need to kind of do that scaling exercise and having to set things up if they're looking at maybe a simple architecture. So I can see it being really relevant in that sort of how many cores in a core-based license model should we need to buy for our sort of needs and also for that sort of architectural choice. So I think this sort of analysis and probably the Linux one when you do it is probably going to be really valuable to support those conversations and giving a client some confidence in how they move forward in their decisions. So I can see it being really useful from that perspective. Yeah, that's just some observations for me rather than any specific question, Vasilij. I think it's good.
Do you think we could have done anything better from the analysis point of view, or anything differently?
Yeah, I probably would have chosen Linux first if I was honest, rather than Windows. That's a more common choice, and if people are looking at a lower cost architecture and something like that. But then again, it's more another level of challenge to set up and administer as well when you're installing SAS.
Just completely coincidentally, we got two customers, both of them moving onto Azure, and both of them happen to be Windows. And that's why we prioritized it first, because we got other projects where this insight was already applicable and useful straight away.
Yeah.
But yeah, Linux is next for sure.
Yeah. Sounds good. And I think it's valuable to have that different cloud offerings as well. There should be some interesting comparisons there. The AMD thing's really interesting as well, the comparison where that sort of previous assumption that Intel is best, so that you sort of saying AMD is a stronger choice. That's going to raise a few eyebrows, I think, in the market.
Yeah, absolutely. Yeah.
Yeah,
and they're also cheaper.
A sponsor of Vasilij.
Yeah, I was hoping that's going to get some attention, the AMD versus Intel. Absolutely.
Yeah.
So Hamid in the chat is asking a question. Could SAS workloads be run and created in SAS app? Hamid, could you expand on your question? Hamad, you could come off mute and ask the question in the microphone if you have a microphone available.
We asked whether any SAS workloads be created on the actual SAS app itself. I know you can monitor them, but could you actually create them if you wanted? Let's say, for example, if you're out of the office or anything like that, and you don't have access to your workstation, your own, like, a workstation, but then you could maybe, if you got your mobile handset with you, you could probably leverage the power of your handset, to create a SAS workload or even a workload. Could that be done on the app itself?
I'm not entirely sure I understand. Let me answer it in a specific way. You can have certain compute environments associated with either VIA or SAS 9 through the application context, and you could assign them to specific machines. So it's perfectly possible that you have some workload handled by some workspace service on some type of the hardware, another type of workload handled by another type of machines on another workspace server elsewhere. Same as on a VIA as well, you could have a multiple compute contexts, and technically speaking, it's possible to configure for them to use various types of hardware. Does that answer the question?
Yes, I think it does. Thanks a lot. Thanks a lot. Thanks.
Anyone else for anything else?
I was wondering about the code, Vasilij. Could you show us the code that you ran again? Maybe there may be some comments from people about what other procedures or something else that may be valid to include that might be meaningful for this sort of benchmarking.
I wonder if this is our resource dashboard. I can see some people logged in because we got the network load and a disk load on here. So has anyone managed to log into SAS VIA and open the data yourself? Did you find anything interesting in the dashboard?
I've opened the VIA, but I haven't seen where the data is.
You mean like a data table? We didn't create a tab there with just a data table, although you could navigate to it from any graph.
Okay, I've just found the menu, so I'll have a look. I was just looking at your last slide, cluster analysis. I mean, it's a really great slide. Just wondered if you could put that in the presentation, because it's like a one which reaches out and grabs you.
This one.
Yeah.
Okay. Yeah. I can incorporate it in the slides. What sort of key learning points would you gather from this slide specifically?
The trends at the bottom, the price per run would be a point of interest, I think. So it's a great graphic to sort of reach out and grab. I was struggling with some of the other slides that you were showing about what they were trying to show, but this one for me was a good one.
Okay, fair enough.
Lesson 4 and lesson 5, I was struggling to understand what I was seeing there.
Okay. Yeah, let me go back to lesson. So lesson 5 is not, you're not gonna get it from those graphs specifically, but what might be useful if I open the slide, the lesson. So this article, the B-type machines, they are very specific. And what many people don't realize today, what's called burstable. So what happens there, if you have a machine that needs to perform in a specific way, the performance of that machine will improve if you have periods when you don't use the CPU. So think of it this way. You come to Azure and they give you CPU, but they don't give you in full. And they will be able to give you more of it when you need it if you have a requirement for the machine that goes up and down. A sort of graph that you could get on the inside that shows you the number of credits and the workloads. As and when you have a workload that's coming onto the SAS, you consume your credits. But once you deplete your credits, then the amount of CPU processing power drops significantly on the B-type machines. So this is ideal for situations where you have a SAS where users only connect only sometimes, or you have a batch processes that only run occasionally, and for most of the time machine is idle, but you can't afford to completely switch it off because you need to be able to handle occasional connections, occasional requests. So that's why I try to make that B one separate. If this wasn't the case for the B-type machines, then the B ones will certainly provide the best performance and value to performance ratio. But because they're burstable, you can't really compare them to, let's say, DC type or A-type machines. Does that make sense about this specific lesson?
Yeah. Thanks.
Okay.
Yeah, I was wondering about those links on the slide, but didn't have time to open them at the time.
Oh, fair enough. Yeah, we'll publish the slides in a video later.
I had another question, Vasilij.
Yeah.
Have you considered SPRI as part of the analysis? So that may be a different way to maybe look at SAS 9 workloads and whether a VIA architecture can do the job, if they're thinking that.
True. But then I was thinking about how for us to best incorporate that. And I was thinking the only way we could do that if we install the programming only interface. Because if you go with the full VIA, there's way too many variables. The RAM memory required for it is a completely different kind of story. So testing the full VIA would be quite tricky for the SPRI only. But the programming only interface could do. And probably what may make sense is to test SPRI programming only versus 9.4M7 and see if performance would be any different. Based on documentation, performance should be exactly the same, but might be worth just double checking, making sure that's the same. If it is the same, perhaps carry on testing with the programming only interface. What do you think?
Yeah, I think that's a good place to start with programming only, because that's going to be the entry point, and it may be an interesting consideration for people. Maybe there's some sort of licensing related benefits as well if they were to go for a VIA license programming only as compared to a SAS 9 traditional. So it's be a good trade-off.
Yeah, you're right. Yeah, for customers, going after VIA sometimes more beneficial than SAS 9 for several reasons. First, support is longer, and second, going with business analytics SAS VIA gives all the SAS access engines for various types of data sources, and there is no SAS 9 package that allows to do the same. So you're right. In some cases, customers should seriously consider VIA rather than SAS 9 for various types of workloads. Okay. Anyone else for any questions? The last round. Then I suggest I'm going to stop at this point in time. So, Alan, I want to put you on the spot. Could you briefly introduce your next presentation next month?
Yes, of course. Yeah, I'm on the spot. So, yeah, next month's presentation is going to be on DevOps with SAS using SAS.js. So it'll be interesting if you're a SAS developer and you'd like to use Git workflows, maybe locally in a VS Code IDE, and you'd like to understand, especially if you're on VIA, how to compile, build, deploy your jobs, how to document them, and also how to test them, which is a new feature that we just released. So do come along if you're a SAS developer and you'd like to work more with Git.
Yeah, the registration is already open. It's on our SUGUKI website. So just where you saw the link for this event, you could register on it. Should be a good session. So,
yeah, the tooling I'm going to show you is all open source. It's all on GitHub, and there's no licensing issues with using it.
So on this note, I see Oksana and Pavel on the call. I just wanted to also thank Oksana and Pavel who are on the call, because they the ones, and Vladislav as well, they the ones that gathered the data for this presentation. They the ones that did the visualizations, and I'm very grateful for them for the excellent job that they've done preparing this content. And on that note, thank you very much.
Thanks very much, Vasilij.
Thank you, Vasilij.
Thank you.
Thank you.
Okay, bye-bye.
Goodbye.
Bye-bye.